Hello students, in this video we will learn what is Hooke's law, what is pressure and how to calculate pressure in fluid. When force acts on a body, force can change the size and shape of an object. Now let's consider this is any undeformed object. So what force can do? Tensile force means tensile force is a stretching forces acting on a material. And compressive forces, with the help of compressive forces, a body can be compressed. Bending forces are responsible for bending any object. Like here we can see that on the outer surface the wire is stretched, but on the inner surface a wire is compressed. So at outer surface there are stretching forces acting, but inside at the inner surface there are compressive forces acting. Torsional forces. Torsional force is responsible to twist or turn any object. Shear forces. Shear force is a force that acts in a direction that is parallel to a surface or cross section of a body. When we put a piece of paper between blades of scissors, it gets divided due to shear forces. How a spring behaves when it is stretched. When a small force is applied, springs are designed to stretch long way, and to measure the change in length of a spring is easy. Weights are referred as the load which are hung at the other end of the spring. These are the weights. When the load increases, the spring stretches and the length of the spring also increases. Initially, the spring shows elastic deformation. Elastic deformation means that the spring will come to its original length when the load at the other end is removed. And when the load is so great, the spring will bear permanent deformation. In this case, in the fourth case, we can see that at the other end the load is so great. So the spring, even after removing the load, the spring will not come to its original position. Means the spring will not retain its original length. Hooke's law. Hooke's law states that extension in the length of a spring directly proportional to the load applied to it within the limit of proportionality. F is equal to Kx, where F is the force load is stretching the spring, X is the extension in the length, and K is a force constant. This is known as the proportionality constant. It is the spring constant which determines the characteristics of a spring, and its unit is F by X, means Newton divided by meter. K is a positive real number. Here a graph between extension and load is plotted, and we can see that at first the graph is a straight line sloping up from the origin. This shows that extension is proportional to the load, means F is proportional to X. At a certain point the graph bends and graphs slope up more steeply. This point is called the limit of proportionality. This is the point beyond which the extension is no longer proportional to the force. This point is also called elastic limit. So many times the definition of limit of proportionality is asked. Please learn this definition, that this is the point beyond which the extension is no longer proportional to the force. If the load is further increased, the spring will be permanently damaged and will not be able to return to its original undeformed length. If we remove load, the graph will not follow the same path of loading. Spring will show some deformation. Here we can see that when we remove load, the spring shows some extension in the length. Important points, that K measures spring's stiffness. It means if the spring is strong or stiff, K will be large, and if the spring is weak, K will be small. Sometimes Hooke's law is formulated as F is equal to minus Kx. In this expression, F no longer means the applied force, but rather means the equal and oppositely directed restoring force. So what is restoring force? Restoring force causes elastic materials to return to their original dimensions. So when we apply load at the other end, the restoring force tries to pull the original back to its original position. Now this is a tabular representation when we apply load, and this is the extension, and this is the total change in the length of the spring. So when there was no load, the undeformed length was 60 millimeter. Let's consider. So extension is 0 here. And when we apply load, we see that the length of the spring increases and the extension is finally calculated as final length minus unstretched length when the load is 0. So here we can see that the extension is 64 minus 60. When the force we apply at the other end 2 Newton, the extension will be 68 minus 60. Many times students perform some mistakes like they calculate extension by subtracting the length from the previous load, but it is not the right way. You have to subtract that value when the load was 0. So when a load is 3 Newton, 72 minus 60 is the extension in the length of the spring. Here we have solved some questions like a spring requires a load of 2.5 Newton to increase its length by 4 centimeter. So force F1 is 2.5 Newton and X1 extension is 4 centimeter. The spring obeys Hooke's law. What load will give it to an extension of 12 centimeter? So first we can calculate K, spring constant. It is 0.625 Newton per centimeter. Now F2 is equal to Kx2. X2 we have given, extension is given. So multiply extension with force constant. F2 is 7.5 Newton. So what load will give it to an extension? 7.5 Newton. Here a spring has an unstretched length of 12 centimeter. When unstretched length means when there is no load at the other end. So its spring constant is 8 Newton per centimeter. What load is needed to stretch the spring to a length of 15 centimeter? This is the total length when you apply load at the other end. So extension will be 15 minus 12. It is 3 centimeter. And K is given. So we can easily calculate load by multiplying K and X. So it is 24 Newton in this case. Pressure is defined as the perpendicular force acting per unit cross-sectional area. Pressure is equal to normal force divided by cross-sectional area, means the component of force which is normal to the cross-sectional area. So that force divided by cross-sectional area gives you pressure. Pressure is a measurement of strength, magnitude of force applied per unit area. It has magnitude only. No direction is associated with it. So pressure is a scalar quantity. Force is a vector quantity. Area is a scalar quantity and pressure is a scalar quantity. Because we use only the magnitude of the force. The unit of pressure are Newton per square meter. The unit of force is Newton. The unit of area is meter square. Unit of force is Newton per meter square. And it is also called Pascal. So which has given a name called Pascal. 1 Pascal is equal to 1 Newton per meter square. 1 kilopascal is equal to 10 to the power 3 Pascal. 1 megapascal 10 to the power 6 Pascal. 1 gigapascal 10 to the power 9 Pascal. Pressure in a fluid. The pressure at a depth h in a fluid of density ρ can be written as pressure is equal to rho gh, where rho is the density of the fluid, g is the acceleration due to gravity and h is the depth. So how we can derive this formula? The force acting at the bottom of tank is due to the weight of water inside it. Let's consider this is a tank filled with the water and the height of the water is h. So the pressure due to this weight, the pressure due to the weight of water at the bottom of the tank is, now volume of water will be area multiplied by height, it is A multiplied by H, and mass of water is equal to, we know, density multiplied by volume. As we know the formula for density, density is equal to mass divided by volume. So we can rearrange the formula. Mass of water is equal to rho multiplied by A multiplied by H. And weight of water, we know weight is equal to mg. So when you divide force, weight of water is force divided by area, you get rho gh. Here the diagram shows a tank that is filled with oil and the density of the oil is given. So calculate the volume. Now volume of tank, we have to multiply these three sides. 1 multiplied by 1.5 multiplied by 2, unit is meter, so volume is 3 meter cube. Calculate the weight of the oil in the tank. Weight of the oil is mg, mass multiplied by g. And mass of the oil will be density multiplied by volume. Density is given and volume we calculate in section A. So it is 2760 kilogram and weight is 2760 multiplied by 10. The value of G, we have taken the approximate value of G. The exact value of G is 9.8, but we can take, this is the approximate value of G. This is 27600 Newton. Then the pressure on the bottom of the tank is caused by the weight of the oil. Calculate the pressure. Now pressure we know we will calculate using the formula force divided by area. Force is due to the weight of the oil. It is 27600 divided by 3. It is 9200 Pascal. Now area will be multiplication of these two sides. 2 multiplied by 1.5. And D, now calculate the pressure using rho GH, this formula. So rho is given density 920, G we will take 10 and H is 1 meter, the height is 1 meter. So pressure is 9200 Pascal. Do you find the same answer? Yes, definitely the both answers are same when you calculate using the formula rho GH and when you derive it, so both answers are same. State which spring has a greater stiffness. Here we can see that the force versus extension graph is plotted for different spring. So we can see that the slope of curve A is steeper than that of B. So this means that spring A has a greater stiffness. And C spring does not follow the Hooke's law because it is a curved line. So state which of these spring does not follow. The answer is C. Thank you for watching this video. I request you to please subscribe, like, share and write your feedback in the comment section.